Yeah, who wants to go first?
Okay, then let's start at the end. You say this, that there are specific solutions for sharing data, and we can model them with protected objects, but they don't implement it efficiently.
Right.
Why don't the sensible compiler providers then make this, don't know exactly how they do it, I'm not a compiler writer myself, but provide it to us as a generic package of some kind, where they have the efficient implementation hidden behind it. In some cases, at least, I expect it would be possible.
Yeah, this is back to the future again. Okay, for those of us who went through the evolution of protected records, protected types, they were a response to a previous generation of Ada, where it was viewed that a task was a sufficient metaphor for all forms of concurrency, and compilers should recognize optimizable forms of concurrency and do it, right? And some compilers did a pretty respectable attempt at that. I think the intermetrics one did, as I recall. At least, no, wait, I guess, no, Ben, you worked on the other one. Didn't your compiler do it? Intermetrics? No, you worked on the, were you on the intermetrics? Which was the other one? Which one did the, which one did passive task, we did the passive task optimization? Back in 883.
I think it was one of those things they talked a lot about, but not many people implemented it.
Yeah. There was a lot of talk about passive tasks. And I know Verdix had something like it, very specialized cases for a while. But I think it was, what was the company that Jean had? Alsys, I think, had some kind of passive task that they bragged about. Yeah. But what it basically what you're saying is, I'm going to have this idiom that I have to be very careful to code exactly in the idiom so it can be recognized. And I could just as well then probably write a generic something, a generic package or something that provides it in easier form for the compiler to, I don't need compiler support then. I just instantiate the generic package and have someone who's very clever code it in whatever language works, with whatever operating system primitives are available, or assembly language. And then I don't have to build it into my compiler. That's probably better.
Yeah. Hyperthreading seems to provide you kind of hardware-assisted time slicing. Is it of use, or is it more evil than good?
Hyperthreading is somewhere on the scale. It's short of multicore, just as multicore is short of really full symmetric multiprocessing.
Many processors have both. That is, they hyperthread each physical core up to 8 logical threads. And I would think that would give you sort of the fractional processor that you've found to be useful for some of these algorithms.
From what I understand of hyperthreading, okay, these were the rationale for hyperthreading, and one of the rationales for multicore is that memory speeds are slower than CPU speeds. And in order to compensate for the slower memory cycle times, we want to bring in larger slices of memory. This goes all the way back to when I started my first job at FSU, when we were running CDC 6000 series machines. And these super words, they bring in off the memory in order to get more bandwidth, memory bandwidth. So if you bring in a large chunk of memory at once, you can get around the memory bandwidth problem. But then you need to have more instructions being executed while you're buffering in this data. So my understanding of they were trying to take advantage of the extra processor cycles while the memory is busy. But I don't think that it gives you, in any way, the full, it's like trying to sneak in part of another thread in the amount of time that you would normally execute one thread during the time that the memory is busy, while the processor is waiting for the memory in the other thread. I don't consider them analogous at all.
You don't think it's like time slicing? It feels like time slicing because you've got now 8 tasks, which are all fairly cheaply runnable.
Oh, they're interleaved, yes.
Right.
But it's not. I mean, I don't know what you mean by like time slicing. How like are you talking about? I guess I'm not sure.
Well, you had
how to
a picture
answer
up there where you showed that you were giving processors, tasks. You were giving them fractional threads.
Yeah.
that's essentially what you're getting with a hyperthread. You're getting an eighth of a thread, for example, an eighth of a processor.
Yeah, I don't know how well you can control it. I mean, with the p-fair algorithm, the time slices are allocated in a way that measures out the fraction of the processor that you need to complete by your deadline. I don't know how you would control that with. I guess you can imagine a hardware mechanism that would do that. Yeah. Yeah.
You started out saying, multiprocessors. Do I need this? Hello.
I can hear you, but
You started out saying multiprocessors are now cheap,
yeah,
inexpensive.
some of them are.
So is that taking the pressure off all these scheduling algorithms? Can't we just have another 10 processors, another 100 processors?
No, they're not. Those aren't cheap. What, an 8-processor chip is about $1,000? Is that cheap?
No. You
No.
can
I mean,
down at your computer store, you can buy a
I can buy a 4-processor.
Core,
I can buy a
whatever.
4-processor cheap for a couple $100.
yeah.
If I go up to 8, it costs me maybe $1,000. If I want to go up more than that, it may cost me a lot more than that. I mean, what I've been reading, at least, about the highest end processors right now is they're targeting it only for super servers, not
Okay.
low end systems.
So next year or the year after, we're going to have a little box with 16 processors, maybe 64 processors. Is that going to make your life easy or more difficult?
That's, I can't say, because I'm trying to understand this, and there's not a lot of information that is easy to lay your hands on, because the companies, on the one hand, brag about what they're going to release, and then they're very stingy about the details of how it works. But present results, the 4 and 8 processor core machines seem to have, from the benchmarks I've been able to see, seem to have bandwidth limitations at memory. Mm-hmm. So the extra processors you have, you can afford to squander them in terms of scheduling the CPU, because the memory is the bottleneck. So yes, maybe you can dedicate processors and don't bother scheduling. That's good. But the higher end processors, now they claim that they're going to catch up. Some of them are talking about using light channels between, sort of interconnect on the chip using light emitting diodes, on the chip. So the claim there is that they're going to catch up, at which point I guess you'll start having to worry about processors again. But you'll still have to worry about how to get the data between one processor and another. And the main kind of applications that they would make sense for, those kind of highly parallel machines, would be highly parallel problems with large volumes of data, image processing, radar processing, audio processing. Yeah.
One more, and then it close. Alan. Okay, Ted, implicit in your concerns was that we at the software end will never be able to influence hardware architectures, and we just have to live with what we're given. And there's good evidence that has always been the case.
If you want it cheap, yeah.
But there is work going on. I mean, just up the road from here at the Barcelona Supercomputer Center, looking at architectures, for example, randomizing cache and getting good predictable behavior from a randomized cache, which is arguably hard real time.
I would argue whether it's hard real time.
Well, we could argue about that, but that's a semantic issue. But there are some architectures, because I think the problems you've highlighted are so acute, there are hardware architecture people beginning to look at alternatives by which we can get more predictable behavior. So I don't think it's quite as gloomy as you.
Well, I was trying to provoke people here. I was told to do that. But it's been the pattern that I've seen that if you spend enough money for custom stuff, you can get it. But the people that we hear at conferences from automobile companies and cell phone companies and so on are worrying about trying to save a penny and looking for volumes of scale and trying to reuse stuff that's good enough for one product in another product. So I'm sure there's hardware solutions, but will people be willing to pay to produce them in a quantity that brings the price down low enough that they're available to us all for the cheap products we want to build? That's one question. The other one is, what is hard real time? Okay, what you described to me is soft real time, and that was, if I had more time, I was going to say that's what we need to do. We need to think softer.
10 to the minus 6 and better. That's hard to me.
If that's all there is. I mean, if it's just the randomization of the cashless effect you're talking about, yeah.
All right. I think we're done. Thanks, Dave.
Okay, thank you.